Guys, just some notes on the extremes on an interval. So what we're talking about the extremes on an interval is the greatest and least value on a graph once the function has been graphed. So the extremes on an interval you can use, so we already know that we can use the gradient function, or we can derive a function to work out the stationary points. And the stationary points, then we can determine whether they're maximums or minimums, okay? So from that then, what we want to look at is if we have the whole domain, so if we know the entirety of the domain for the graph, we can then work out the global max and the global min, as opposed to the local max and the local min, okay? So when the domain is restricted with a specific domain, we look at its boundary conditions, okay? And boundary conditions, you're going to see them in action in a second. So for continuous curves like polynomials, we can look at, and we only need to look at, the stationary points, the y-intercept, and the boundary conditions. Okay, so it's not necessary to look at everything, because obviously these polynomials are continuous. So we just look at the stationary points, the y-intercept, and the boundary conditions. The maximum of a function over a given domain is known as the greatest value. Okay, and the minimum of a function over a given domain is known as its least value. Okay, and you'll understand that a little bit more once we have the graph in front of us. So the example that we're going to look at is finding the greatest and the least values of the function f of x is equal to x squared minus 4x plus 3. So that's my function there, and I know just from looking at that it's a quadratic, but I only want to talk about it within this domain here. So from negative 4 to 3, where the x values are from negative 4 to 3. Okay, so what I'm going to do in order to do that is, if you just think back to the previous page, we needed the stationary points, the y-intercept, and the boundary conditions. Okay, so the first thing I'm going to do is work out my stationary points, and I'm going to write in white because it's on an orange background. But my stationary points, in order to do them, I'm going to have to find my gradient function. So I'm going to have to derive f of x. So it's going to give me f dash x, which is equal to 2x minus 4. And in order to work out the stationary points, I know that their gradient is going to be 0, so I just let this equal to 0, and I'm going to solve for x. So 2x is going to be equal to positive 4, so then x is going to be equal to 2. Sorry, that's a very poor x. Okay, so when I know my x is equal to 2, I can now find the y value by plugging back into my original. So f of 2 is equal to 2 squared plus 4 times 2 plus 3. And I get a y value of negative 1, which means my stationary point is 2, negative 1. So for this function, I actually only have one stationary point, so that makes it a little bit easier. And I already knew that anyway because it was a parabola or a quadratic. So what I'm going to look at now is the fact that just to decide whether it's a local minimum or a local maximum, I'm going to look at either side of my x coordinate like we've already practiced using the table. So when x is less than 2, if I plugged in any value less than 2, I would get the gradient of less than 0, which means at that point then it's decreasing. So once my function is to the left of 2 or less than 2, it's going to be decreasing. And when my x is greater than 2, my f dash x is going to be greater than 0. Oops, sorry, my greater than sign's not very good. Greater than 0. Okay, so that means that it's going to be increasing. So I know that my stationary point, 2, negative 1, oops, can't spell, increasing. So I know that my stationary point 2, negative 1 is going to be a minimum stationary point. Okay, so now I'm going to look at, so I've done my stationary points, I'm now going to look at my boundaries. Okay, and boundaries are the conditions that I was given, which means my restrictions, so therefore my domain was from negative 4 to 3. So I'm now going to look at my y value when my x is negative 4. If I can find my white pen, yep. So I'm going to do f of negative 4, and I'm going to work out my y value. So I get negative 4 all to be squared minus 4 times negative 4 plus 3, and I get 35. So I know that my point is negative 4, 35. So at the greatest x value on that graph, which is negative 4, my y value is 35, so the point is negative 4, 35. I now need to go with the lower boundary, which is, sorry, this is the upper boundary, which is 3, is going to be 3 squared minus 4 times 3 plus 3, which gives me a value of 0. So I now know that my point when my x was 3, my upper boundary on my function is going to be 3, 0. Okay, so what I've got now is my stationary points and my boundaries, and the one other thing that I have to do is find my y-intercept. So I can find my y-intercept. In order to find my y-intercept, I have to let my x equal to 0. So I'm going to let my x equal to 0. Again, I'm going to find f of 0, which is equal to 0 squared minus 4 times 0 plus 3, which means equals 3. So my point is 0, 3. Okay. At this point now I have 4 points. So 2, negative 1. Actually, that's not very easy to see. 2, negative 1, negative 4, 35, 3, and 0, and 0, 3. So I've found my stationary points, or just point in this situation, my boundaries for the lower x value in the domain and the upper x value in the domain, and my y-intercept when I let my x equal to 0. Okay, so these 4 points now are going to allow me to graph or sketch my function. So over here I've just rewritten my 4 points that I had from the previous page, and I'm just going to plot them. So 2, negative 1 is going to be just under the x-axis there. Okay, and negative 4, 35 is going to be up here. Oops, they're disappearing, sorry, not on my pen. So 2, negative 1 is just going to be there. Negative 4, 35 is going to be about there. 3, 0 is going to be my x-intercept, and 0, 3 is going to be my y-intercept. Okay, that probably looks more like 0, 5, but it's just the pen, sorry. And now I'm going to sketch my parabola. So hopefully I don't sketch it like that again, because that would be very crooked. Ooh, that was pretty good. Okay, so that is the parabola within the boundary that I was given from negative 4 to 3. Okay, so obviously it's not the entire continuous polynomial, but it's just within my domain. And you can see here on the right hand side I've got my domain negative 4 to 3. Okay, so now what I can do is I can look at that graph and I can see that my lower boundary is at negative 4 and my upper boundary is at 3. And what I need to do is find the greatest value and find the least value. So my greatest value from my graph on the left hand side is 35. So within those boundaries my graph never goes above 35. So my 35 is my greatest value, and my least value within that, on that graph within the domain, is going to be negative 1, because it's never going to go below this point here. Okay, so it's negative 1. This one here is the positive 35. So my greatest value on this graph within this domain is plus 35, and my least value is negative 1. Okay, and that's pretty much how you work out the extremes on an interval. This one might have been a little bit easier than some that you get because it was a quadratic, so there was only one stationary point, but we're more than capable of finding many stationary points. So that's it. Thanks.